In today's world, it's unlikely that you haven't heard the term multiverse, whether through superhero movies, collaborations between content creators, or because you're studying physics. The word is out there, but what exactly is the multiverse? Are you sure you understand the concept? How clear is it to you? Did you know that there are levels of multiverses? What would you think if I told you that we might be close to proving its existence? This topic is fascinating. The idea of the multiverse suggests that our universe, with all its galaxies, stars, planets, and physical laws, is not the only one that exists. This implies that there could be an enormous, perhaps infinite, number of universes, each with its own characteristics and physical laws. To some, this might sound more like science fiction than science, but in reality, the concept has emerged from serious research in theoretical physics, cosmology, and quantum mechanics. But where does the term come from? Who coined it? The term multiverse was created by the American philosopher William James in 1895, although at that time it didn't refer to the concept we know today in physics. As we mentioned, the multiverse suggests that there could be an indefinite number of universes existing simultaneously, but separate from our own universe. These universes could have different laws of physics, different fundamental constants, and different configurations of matter and energy. It's important to note that scientists who propose the multiverse don't see it as a tangible place we could travel to, but rather as a set of possible realities that exist beyond our capacity for direct observation. This concept is closely related to the Big Bang theory and physicists' attempts to understand the structure and origin of the cosmos. As is well known, the standard model of the Big Bang describes how the universe expanded from an extremely dense and hot state approximately 13.8 billion years ago. However, this model raises complex questions that could be resolved if we assume that more universes exist. One of the key ideas that has given rise to the multiverse hypothesis is cosmic inflation, proposed by physicist Alan Guth in 1981. Cosmic inflation suggests that in the first instant of the Big Bang, the universe experienced an extremely rapid exponential expansion, which explains the homogeneity and observable size of the current universe. However, some versions of inflation theory imply that this rapid expansion did not occur uniformly. Instead, there could have been pockets of space-time that expanded differently, forming other universes with different properties. Physicist Andre Linde proposed an extension of this idea called eternal inflation, according to which inflationary expansion never completely stops, leading to the continuous creation of new universes. In this framework, each universe is like a bubble that detaches from a larger inflationary state, creating what is known as a bubble multiverse. Now, the idea of the multiverse can take many forms depending on the physical theory being considered. Cosmologist Max Tegmark has provided a taxonomy of universes beyond the usual observable universe and has divided them into 4 levels. These levels are organized in such a way that subsequent levels encompass and expand upon the previous ones. Let's look at each of them. First, the Level 1 multiverse, or an extension of our universe. In this model, the multiverse doesn't imply universes with different physical laws, but rather very distant parts of our own universe. According to this idea, the universe we observe is only a small portion of a much larger universe that extends indefinitely in all directions. Given that the universe is so vast somewhere far away, there could be regions of space that appear to be separate universes simply because they are outside our observable horizon. According to Tegmark, at this level of the multiverse, there are infinite repetitions of possible particle configurations. This means that if we traveled far enough in space, we could find an exact copy of our own universe. The second level consists of inflationary bubble universes. This type of universe is based on the idea of eternal inflation that we mentioned earlier. In this model, each bubble that emerges from inflation would represent a universe with different physical properties, such as the intensity of fundamental forces or the amount of dark energy. These universes could have laws of physics radically different from those of our own universe, which means they could be completely inhospitable to life as we know it. According to calculations, these universe bubbles could exist in a multidimensional space, although we would have no way of interacting with them, as they are separated from us by distances greater than the speed of light, somewhat like galaxies. Continuing with the levels of multiverses, we arrive at the third level, the many worlds interpretation of quantum mechanics. One of the most fascinating concepts related to the multiverse comes from quantum mechanics, the theory that describes the behavior of subatomic particles. The many worlds interpretation, proposed by physicist Hugh Everett in 1957, suggests that every time a quantum measurement occurs, the universe splits into multiple copies. Each of these copies contains a different result of the measurement. This type of multiverse is the most abstract, as it suggests that new universes are created at every moment, representing all possible configurations of reality. For example, if you decide to tell someone you like them, instead of not doing so, there should exist a universe in which you did tell them, and another in which you didn't. This model implies that there are an infinite number of versions of yourself living in parallel universes. The next multiverse is level 4, the mathematical multiverse. The level 4 multiverse is the most speculative and abstract. This type of multiverse is based on the idea that any coherent mathematical structure could represent a real universe. In other words, all possible universes, described by different mathematical theories, exist at some level of reality. Although this approach is difficult to prove experimentally, it suggests that any mathematically possible universe has the same probability of existing as our own. But which arguments prevail? Those in favor of the multiverse or those against it? Let's look at the arguments in favor. One of the main reasons scientists seriously consider this idea is that some well-established theories, such as cosmic inflation, seem to imply the possibility of other universes. However, inflation has its detractors. Some cosmologists have proposed alternative models, such as the cyclic universe, which posits that the cosmos goes through cycles of expansion and compression. Neil Turok, a physicist at the University of Edinburgh, was one of the developers of this theory in 2001. According to Turok, inflation doesn't offer enough verifiable predictions. The idea of the cyclic universe also helps explain dark energy, that mysterious force that accelerates the expansion of the universe. And since the 1980s, it has been suggested that this energy could decrease over time in a series of jumps. Turok and Paul Steinhardt proposed that as dark energy decreases, the cycles of the universe lengthen, which would make our current universe with low dark energy the most probable state. The search for evidence of the multiverse has also led cosmologists to study the cosmic microwave background, that residual radiation from the Big Bang. Some scientists have investigated the possibility that collisions between bubble universes predicted by inflation leave traces in the microwave background in the form of circles. In 2011, researchers found 4 areas in the sky that could reveal these marks. Additionally, they are currently developing a quantum experiment to better understand how vacuum bubbles form and collide, which could improve predictions about the multiverse. Roger Penrose, a physicist at the University of Oxford, has suggested that cyclic universe models could also leave signals in the microwave background. Likewise, some scientists have proposed that black holes from previous cycles could survive and be detectable in our current universe. There is a more recent theory known as the mirror universe. In this model, time is reversed at the Big Bang, which would further simplify the explanation of the universe. This theory could also offer answers to the enigma of dark matter, suggesting that it is made up of massive neutrinos from a mirror universe. 2 years ago, in 2022, a team of researchers demonstrated that this would imply that the lightest neutrino has non-zero mass, a prediction that is being tested in studies such as those at the Vera C. Rubin Observatory. If confirmed, these theories could bring us closer to discovering evidence of the existence of other universes. Sounds fascinating, doesn't it? Could it be true? What do you think? Now let's hear the arguments against. One of the main criticisms of the multiverse concept is that so far no direct evidence of its existence has been found. Universes outside our own observable horizon are, by definition, beyond our capacity for observation, which makes it difficult or impossible to prove their existence experimentally. Some physicists, like cosmologist George Ellis, argue that the idea of the multiverse is more in the realm of philosophical speculation than verifiable science. According to them, if we cannot obtain experimental evidence of other universes, then the idea of the multiverse should not be considered a scientific theory, but rather a conjecture. But there is a bigger reason why some don't think the multiverse exists, and it has to do with the anthropic principle. How so? Let's see. One of the most amazing discoveries of recent decades is that the universe seems to be perfectly tuned to allow life. For life to be possible, certain values in physics must be within very specific ranges. An example of this is dark energy. If this energy had been a little stronger, matter would not have clustered, which would mean that stars and planets would not have formed. Without that structural complexity, life would obviously not have been possible either. On the other hand, if dark energy had been weaker, it would not have counteracted gravity, and the universe would have collapsed in the first fraction of a second, and likewise, life could not exist. So dark energy seems to be adjusted to a just right value, similar to the Goldilocks story. Remember that tale about the porridge? A porridge that was just right. This is just one of many examples of what physicists call fine-tuning, and which has puzzled many scientists. One of the most popular explanations, in fact, is that we live in a multiverse. Like in a lottery, if there are enough universes with different numbers in their physics, some will end up with the right conditions for life, as happened with ours. For a long time, this was considered a reasonable explanation. However, experts in probability mathematics have pointed out that this conclusion may be an example of the inverse gambler's fallacy. This error occurs when someone assumes that if an improbable event occurs, there must have been many previous opportunities that made it possible. To better illustrate this, imagine you're playing bingo and you match all the numbers in the first minute of the game. The first thing that might go through your head is, what's going on? But you might also conclude that there could be many people playing bingo across the country that night, which would make it more likely for someone to match all the numbers. However, this is a reasoning error. The probability of you winning doesn't depend on how many people are playing in other bingo halls. Each draw or play has the same probability of occurring independently of the others. Some think that multiverse theorists commit a similar fallacy by assuming that, given that our universe has the right numbers for life, there must be other universes with the wrong numbers. This is where the anthropic principle comes in. Defenders of the multiverse argue that, because we exist, we could only have observed a universe compatible with life. We couldn't be in a universe with the wrong numbers. Although this reasoning is partly valid, it doesn't necessarily imply the existence of other universes. To make an analogy closer to fine-tuning, let's suppose a sniper is aiming at you and has orders to shoot you if an incorrect number comes up in the bingo. In that scenario, you could only have observed the correct numbers to survive. Similarly, we can only observe a universe compatible with life. But this doesn't justify the assumption that there are many other failed universes. So is there scientific evidence for the multiverse? As you can see, the answer is ambiguous. It's a topic that requires much reflection and study. And with this, we conclude this analysis of the multiverse. What do you think about this fascinating topic? Do you consider it possible, or does it seem unlikely to you? The discussion about the multiverse continues in the scientific and philosophical realm, and we will surely continue to hear about new theories and discoveries in the future.